Hi guys, we are going to start by going over numbers 8 through 10 on the 2.4 investigate. I've copied them into a Google Doc so that I can draw on here and go through how to do them. So number 8 says, we know that in order to accelerate, there must be a net force present. Draw a force diagram for each coin after the coins have been released and are already in motion. Remember that they're both in free fall. So I'm going to start with the penny that was just dropped. So here's my penny that was just dropped. And I need to make sure that I remember which forces are acting on this penny. So the first force that I know is acting on this penny is gravity. So the first thing I'm going to do is draw an arrow that says that there is the force of gravity acting on this penny. The second force that I know is acting on this penny, well, is there one? There isn't. So I know that at this point for the dropped penny, I am done with my force diagram. So what I'm going to do is I'm going to go ahead and write force of gravity right next to this. And I know that I am now done. Now I'm going to look at my force diagram for my penny that is in motion, the projectile penny. This is the one that's a little bit different because there's only one force acting on the first penny. There's two forces acting on this one. Obviously, we know that because it is falling, there is the force of gravity acting on it. So I know that that is my first force that I need to draw in this diagram. However, because there is a horizontal component to the motion, there's also an applied force, and that is applied horizontally. Both of these forces are completely independent of each other. There's absolutely nothing that is different about these forces, there's absolutely nothing that is the same about these forces. So while this right here is the force of gravity, which I'll draw right here, and this right here is the applied force, these forces are completely independent of each other. They have no bearing on what the other one does. So I'm going to make a note of that right here. These forces are completely independent of each other and act in different directions without, and that's really important, affecting the other. Okay, now that we have that done, we know that they're both in free fall because they both have the force of gravity acting on them. We're going to move on to why these two won't affect the other in just a minute. So number 9 says, why do projectiles land at the same time as objects that are dropped? Discuss forces in your answer. The answer to that is because the force of gravity acts independent of the force applied by the penny launcher. Because this is the case, this means that the projectile, the acceleration due to gravity acting by the projectile acting down, is going to cause the penny to fall down at the exact same rate as the projectile that is just in free fall. However, the reason that it goes horizontally is because there's that applied force acting horizontally. So what I want to make sure that you know is that the force of gravity will act on the same mass in the same way as long as they are dropped or launched from the same height every time. So even though there is an extra force applied to the first penny, the second penny, they're still going to act independent of each other. They will still fall at the same rate. Then, number 10 says, in order to get a projectile to land the furthest horizontal distance from its release point, what would you want to do? We changed our lab yesterday in two different ways. The first way was that we increased the height of the projectile. If we do that, we are increasing gravitational potential energy, which increases kinetic energy when released. We also increased the applied force or the elastic potential energy, which increases kinetic energy when released. Go ahead and get on Edmodo and post your question or comment about this podcast. Thanks so much, guys.